Okay, so for this example, we want to show that this implicitly defined function solves a differential equation. And this is very different than the previous two problems that we just got done going through, because this time around, we actually just wanted to take the implicit relationship between the variables, take the derivative, and then rewrite it so it matches the differential equation. So when we take our equation, we're going to have our x squared, y squared, minus 3x plus 4y equals a constant c. And when we take the derivative of both sides of this, d dx, we're going to have to make sure we honor all the rules of calculus. And the first thing you'll notice is that the derivative of the first term is actually a product because y is a function of x. Off to the side, you might want to remind yourself that y is equal to a function of x in this case. So because of that, we're going to take our derivative and we're going to have our product rule. So the derivative of the first, x squared, is 2x. That's now times the second plus the first, which is x squared, times the derivative of the second. And when you take the derivative of the second, you have to make sure that you honor, again, the rules of calculus. That's a function squared. So by the chain rule, that's 2 times y prime. And now moving on to take our derivative, the derivative of negative 3x is just minus 3. And then the derivative of 4 times y is 4 times y prime. And then the derivative of the constant c is equal to 0. So now what we want to do is organize our terms, and we'll first grab the 2xy squared and the minus 3 together. So that's going to be 2xy squared minus 3. And then we're going to have our other terms, which is going to be the x squared 2y y prime and that. And we'll write those down next. So that's going to be x squared 2y y prime plus 4y prime is equal to 0. You notice in those last two terms, there's a common y prime that will factor out. So again, we've got 2xy squared minus 3 plus now 2x squared y prime plus, actually I've lost a y there, so let me erase and back that up. So again, we're going to have our 2x squared y prime plus 4y prime is equal to 0. And you notice that third and fourth term, they both share a common y prime, so we can factor that out. And when you do that, you're going to have a 2x squared y plus 4 times y prime is equal to 0. And believe it or not, we're actually very, very close, because remember that y prime in the Newton notation is the same thing as dy dx in the Leibniz notation. So we can just swap out that y prime with dy dx. And so we end up with 2xy squared minus 3 plus parentheses 2x squared y plus 4 times dy dx. And that's equal to 0. And you notice that is the same exact differential equation as we wanted to prove up here in the statement of our problem. So we've shown by implicit differentiation that the derivative of this equation here is equivalent to that differential equation. And our problem is finished.